Hello viewers, in today's class we are going to discuss a very important problem from differentiation, right? So here what we are going to do, we are going to find out the derivative of one function with respect to another function. So here we are given the problem, that is, find the derivative of tan inverse of square root of 1 plus x square minus 1 over x with respect to this function, that is tan inverse 2x times square root of 1 minus x square over 1 minus 2x square at x equal to 0, right? So let us start, and here what we will do, see, we are given two functions, right? So these two are inverse trigonometric functions, and let us take this function as u, and this function can be taken as v, right? So we are taking this function as u and this function as v, and we are to find the value of du over dv, right, at x equal to 0, right? So first we'll find du over dv, and then we'll substitute x equal to 0. Now before finding out du over dv, let us first simplify these two functions, right? So we'll simplify these two functions by making a proper substitution. So let us first take this function u, right? So we'll try to simplify it by making a proper substitution. So here let us take x is equal to tan theta, right? So tan theta we'll put here. So we have tan inverse, and we have square root of 1 plus tan square theta minus 1 over tan theta, right? And now we can simplify it by making use of the trigonometric identities, and we know that 1 plus tan square theta is secant square theta, right? And here we have tan theta, and now this is tan inverse, and we can take sec square theta out of this square root sign. So we have simply sec theta minus 1 over tan theta, right? Now we can further simplify it by making the substitution 1 over cos theta minus 1 over sin theta over cos theta, right? So now let us further simplify it. We have tan inverse, and if we take LCM here, we have 1 minus cos theta over cos theta, and then here we have sin theta over cos theta, right? Okay, so now this cos theta and this cos theta get cancelled, and now u can be written as tan inverse 1 minus cosine theta over sin theta, right? Okay, now again making use of the trigonometric identities, we have 1 minus cos theta is equal to 2 sine square theta over 2, right? And sin theta is 2 sine theta over 2 cos theta over 2, right? So now this 2 and this 2 get cancelled, sine theta by 2 and 1 sine theta by 2 get cancelled. So we have tan inverse sine theta over 2, and here we have cos theta over 2, right? And sine theta over 2 divided by cos theta over 2 is tan theta over 2, right? So now these tan inverse and tan, these two get cancelled, and we are left with theta over 2, right? Okay, so now we have obtained u is equal to theta over 2, where x is tan theta. So theta can be written as, from here we can write theta is equal to tan inverse of x. So now u is half tan inverse x, right? So the simplified form of u is 1 over 2 tan inverse x. So now we can write u as half tan inverse of x, right? So now let us simplify this function v. Now viewers, we can simplify this function v in a similar manner as we have done in case of u, and here in this case we have substituted x equal to tan theta, but here the proper substitution is x is equal to sine theta, right? So now this function v, it becomes tan inverse, and taking x equal to sine theta, we have 2 sine theta and square root of 1 minus sine square theta, and in the denominator we have 1 minus 2 sine square theta, right? And again at this step we'll make use of the important trigonometric identities, and we have tan inverse, and this is 2 sine theta, and 1 minus sine square theta is cos square theta. Here we can write cos square theta, and 1 minus 2 sine square theta is equal to cos of 2 theta, right? So now here we see that how important the trigonometric identities are to simplify these type of problems, right? So now 1 minus 2 sine square theta is cosine 2 theta, and now we can write tan inverse, and here we have 2 sine theta. Square root of cos square theta is simply cos theta divided by cos of 2 theta, and 2 sine theta cos theta is sine of 2 theta, right? And here we have cos of 2 theta, right? Because this is again an identity, that is sine 2 theta is 2 sine theta cos theta, and here tan inverse and sine over cos is tan, so we have tan 2 theta, and again these two get cancelled and we are left with 2 theta, right? So here we are cancelling this term and this term by making use of the concept of principal value of inverse tan function, right? Okay, so we have 2 theta, and see from here we have theta is equal to sine inverse x, right? So here we can write 2 sine inverse x, right? So now we have obtained the value of v as 2 sine inverse x, right? So viewers, in such type of problems what we usually do, we simplify the two functions in this way, right? So now we have these two simplified forms, and let us proceed further. So now we have to find du over dv. So now du over dv can be written as du over dx and divided by dv over dx, right? So now in the numerator we have the derivative of u with respect to x, so we have d by dx of u, and u is half tan inverse x, right? And in the denominator we have dv over dx, that is d by dx of v. V is 2 sine inverse x, right? So now this is half, and we have the derivative of tan inverse x, and here we can take 2 outside, we have the derivative of sine inverse x, right? So now half and 2, it becomes 1 over 4, and we know that the derivative of tan inverse x with respect to x is 1 over 1 plus x square, and the derivative of sine inverse x is 1 over square root of 1 minus x square, right? So now we can write this expression as 1 over 4, and we have square root of 1 minus x square divided by 1 plus x square, right? So the derivative of u with respect to v is 1 over 4 times square root of 1 minus x square over 1 plus x square. So now we have to find the derivative of u with respect to v at x equal to 0, right? So here we can take x is equal to 0, so du over dv at x equal to 0 is equal to 1 over 4, and here we'll take x equal to 0, right? So we have square root of 1 minus 0 square, and here we have 1 plus 0 square, and we see that we have 1 over 4. This is 1, this is also 1, and we are left with only 1 over 4, right? So the derivative of u with respect to v at x equal to 0 is equal to 1 over 4, right? So viewers, this is how we solve this problem.